All right, so time has come. Let's go ahead and get started. I want to welcome all of you this evening, and we've still got some people joining. Go ahead and come on in and get situated. But good evening to those of you in the Americas, and good morning to those of you east of me in Europe and Asia. We really have an international list of registrants joining us. I'd like to welcome you to the Potomac Valley Radio Club's webinar series. I'm Ken Clairbout, K4ZW, President of PVRC, and we're privileged to have an excellent program for you, design, construction, and maintenance of antennas and towers for storm survival and long-term reliability by Frank Donovan, W3lpl. Frank is owner of one of the most successful multi-multi contest stations in all of radio sporting. No doubt his call is quite familiar to most of you here. But more importantly, he's the Chief Design and Construction Engineer for the station, which makes him eminently qualified to speak on this subject. I've been privileged to be part of Frank's team for many years and as one of his 40-meter operators for w3lpl DXCW. In all those years, I can honestly tell you I don't ever recall even a minor failure on any band for that matter that has adversely impacted our effort. It's a remarkable achievement when you consider all of the equipment that is pushed to the limit during a 48-hour contest. The results, well, they pretty much speak for themselves. We'd be happy to take questions during this presentation. As I mentioned before, you have two options. One is to use the text-based box, question box. You can submit that. Or if you have one microphone connected, you can go ahead and raise your electronic hand and I will unmute your mic. Otherwise, everyone, mic will remain muted for the duration of the presentation. And I'm going to be monitoring the questions while Frank's doing the presentation. So if you have a question and you raise your hand, just sit tight. We will get to it. So with that, I'm going to turn it over to Frank so he can tell us how to apply what he's learned over all these years to our own stations. And Frank, go ahead. It's all yours.
Well, hello, everyone from the U.S. and from overseas. And welcome to the W3lpl webinar on design, construction, and maintenance of antennas and towers. But this is from a little different perspective than most of you have probably participated in, and that is this presentation, first of all, is a set of checklists. They're intended to be used not only for the purpose of supporting the presentation, but also to be used when you consider building a new antenna system or when one has been up in the air for a few years and you're wondering how you preserve it. So I hope this proves to be useful. Well, Ken, I've run into my first problem here.
Okay.
I don't know why I can't change slides here all of a sudden. Didn't have that problem before.
No, I know we tested it. It worked fine. All right, well, stand by, folks. No doubt we'll have some of these issues as we go along. But let me just, yeah, I see your mouse moving on there.
Yeah. But,
try your page up or page down,
yeah,
bottom.
that's what I'm doing, and it no longer works. And it worked fine before you popped up this screen on my end. It worked perfectly.
Well, maybe if you want to try close the application and reboot the application.
Yeah, let me do that. Well, I've totally lost control of my own screen.
Computer.
Yeah, there we go. So I don't know what was going on, but well, I noticed
that's probably not. You're not using
went away.
You're not using one of those old 386s that you have CT on.
No. But I still have some of those in the pocket. Okay.
All right, carry on.
So this first slide is just a schematic representation of a typical guide tower and antenna. And you'll notice in the schematic, and I won't go through it in detail because we'll cover every one of these elements, but you'll see everything in this schematic all the way from the top of the tower with a mast and a Yagi and a supporting truss all the way down to the ground level where you see foundations and ground rods and transmission lines coming over to the tower and kind of everything in between. But that's not all you have to worry about, because in terms of long-term survival, this nice new antenna system in tower is subject to wind and the passage of time, ultraviolet radiation, rain, perhaps very, very heavy rain in some areas, snow and ice. And in many parts of the world, the soil is also unfriendly to tower foundations and ground systems. So all of these things are factors that will wear away at your antenna system despite the very best job you might have tried to have done. So let's get started. The presentation takes the form of checklists all the way through the entire presentation. And for each of the elements of a tower and antenna system, there's one checklist that considers some of the important factors when you're designing and building a new tower and antenna system. And then the second slide deals with some of the maintenance things that you might consider in order to keep this system functioning in tip-top shape for a very long period of time. I will not read these slides, but what I will do is focus on some of the important points. If there are any questions about some points that I don't happen to discuss, I'll be happy to speak about them. By the way, before I get into the presentation, for those who aren't aware, there's a very excellent reflector where these sorts of questions and discussions come up every day. And it's on the contesting.com website, and it's a reflector that you can get to from that website. It's called Tower Talk, Towertalk. And a lot of these topics are discussed there from time to time, and if you're planning a new system or thinking about a maintenance problem that might have come up, it's a very, very fine place to raise these kind of questions and get really useful answers. So we're thinking about building a new tower, and what are some of the things to consider? Well, a lot of people, when they design a tower, think about their current application, but if you're going to have a tower for a long period of time, you might want to think also about what else you might want to do with it 5 or 10 years in the future, so that you're not forced to remove it because you didn't give any consideration to that. In terms of loads on a tower, you know, a lot of times we think about the antenna system that goes up on top of the tower, but sometimes we forget about other things that we attach to it, like wire antennas. And I'll just give you an example of something I learned the hard way. I installed all my current towers 25 years ago, and hanging among my towers are some very large wire antennas for 80 meters and 160 meters. And they were attached to the tower using a pulley and then a rope that went straight down to the ground. And that put tremendous loads on the tower when those antennas got coated with ice. And it nearly destroyed several of the towers. And I didn't even think about the extra forces that would be applied to the tower when ice accumulated on literally 1,000 feet of rope and wire that were attached to several of the towers. And I was very fortunate that the towers did not come down. The load was tremendous from that ice. And don't forget, too, that transmission lines, particularly if you have lots of them, especially the large heliax transmission lines for VHF and UHF, add substantially to the tower load, especially when they get covered with ice. Depending on where you live, you probably know better than anyone else what the expected wind loads are and ice loads. But there are site-specific situations that can be dramatically different than other areas. Certainly here in the Washington, D.C. area, the mountaintops have especially difficult situations for ice and wind. And several of the ham stations owned by members of the PVRC are on these mountaintops, and the conditions they experience are truly amazing. Wind loads 90 miles an hour or more, but more importantly, in the mountaintops here around the D.C. area, it's fairly common. That is, at least every 4 or 5 years to get ice loads of 1.5 or 2 inches. And believe me, that takes the design of a tower and antenna well beyond what most hams are able to deal with. Ice loads. You know, you might think that that's kind of a balanced load, but it turns out the big problem that happens with ice is when it melts. If you've ever seen a heavy load on a Yagi, the Yagi's stressed, of course. It looks terrible while the ice is up there. But if you watch what happens when the ice comes off, that often is when the very serious damage occurs. Because the ice comes off the antenna in a little bit at a time, and the antenna becomes severely unbalanced. And that's when the damage is likely to occur as the ice falls off that antenna in an unbalanced way, creating huge forces. And for any of you that have ham stations near the ocean, there's a whole set of unique conditions having to do with corrosion, and a whole set of special things you have to do in terms of paints and other protection to keep that corrosion away from the tower and guy wires. And that's kind of a special case, but it's real important. At the bottom of this slide, tubular tower sections are a bit of a problem when they've been exposed to difficult conditions for many years. And the only thing I'll caution anyone who intends to use a used tubular tower section like Rome 25 or Rome 45 is be very careful to inspect those tower sections for corrosion. And if in doubt, they really shouldn't be used. They could be very dangerous. In terms of maintenance, when you build a new tower, you really should inspect it a year after you install it, just to be sure that nothing surprising has happened. And then after that initial inspection, certainly every 3 years, you should do a very comprehensive inspection of your tower and antenna system. It really doesn't take that long. Go through these checklists a little bit, think about the things you want to look at, climb the tower or get one of your friends to climb it or pay someone to do it, and check it over very thoroughly. And then after you do that, the tower should be good for another 3 years. On very tall towers in particular, towers over 100 feet, one of the things you should do is to check that the tower is plumb, that is, that it's vertical, and that it hasn't become twisted. Except for very large antennas, most hams won't have the problem of a tower twisting, but it's very common to see hams with towers that are no longer vertical. In order to check a tower to see that it is vertical, the most practical thing to do is use a surveying instrument, and perhaps you can borrow one. Or another real easy way to quickly check it is to use a plumb bob, hold it in your hand, let it drop to the ground, and then compare the tower in the distance to that string that's in front of you. That's a good, quick and dirty way to do it, but a better way is a surveying instrument. Certainly you want to pay attention when you're doing a maintenance check on the tower, is to look especially for any damaged or loose or corroded components, especially the trusses on the tower. If there have been any serious wind loads or ice loads on the tower, you want to check those welds. And especially the most likely place they're likely to fail is near where the guys attached to the tower. Be very careful to check those if the welds are still in good shape. One of the most common problems with tubular towers is that the weep holes at the bottom of the tower might have become jammed with debris that's gotten into the tower. So check those for obstructions. And by the way, a fairly common, more common than you would think, problem with obstructions of these of tubular tower sections is that sometimes people forget to take tower hardware out of the legs. When new Rome towers are shipped, often the tower hardware is packed in the legs, and people install these towers and didn't realize the tower hardware was in there, and it can jam those legs, and things can accumulate there. So before you install a tower, check that the legs are all clear of obstructions and there's nothing jamming it already. Okay, so let's move on to the tower foundation. All the manufacturers have published designs. It's always wise to use their designs. If you live in an area that's subject to heavy frost, you might want to modify that design to be a little bit deeper. Probably the most common error that hams make with foundations is to not have the top of the foundation well above the surrounding surface of the earth, it's the nearby ground. You know, it's pretty common to see hams that thought, well, someday I'm going to take this tower down and I don't want to have to worry about destroying the top of the foundation, so I'll just end the foundation a few inches below the surface of the ground. Well, this is a prescription for disaster. It's very difficult to keep the top of a foundation clear if it's at ground level or slightly below. It will, dirt and leaves will accumulate there. The result will be that the top of the foundation will be continuously wet, and you'll develop corrosion at the point where the tower attaches to the foundation, and that can lead to tower failure in just a relatively small number of years. So the best thing to do is to raise that foundation about 6 inches above the ground, and then occasionally check the foundation when you're around it. If anything is accumulated on it, it should be removed. During construction, if you're building a tubular tower and you've decided to embed that tower in the concrete, you should be very careful about drainage at the bottom of the foundation. Each of the legs must drain into gravel at the bottom of the foundation, and if you don't provide for that, particularly if an area that's subject to freezing, you're going to have a problem with those tower legs cracking right where they enter the foundation. In areas that are subject to salt spray, this idea of embedding towers into concrete is probably one that you really shouldn't do, because you can get salt water accumulated in those legs and it can do a lot of damage. So the best thing to do if you're in a waterfront, oceanfront location is to use a pier pin foundation. So the takeaway here is corrosion at this interface between the concrete and the tower legs is really the key point, and you really want to pay attention to that. Some of us actually apply some paint to that junction just to make sure that it stays clear. In terms of tower foundation maintenance, inspect it once every 3 years is okay. Whenever you're out near your tower, take a look and see if any junk has accumulated on that foundation and clear it off there if it has. If you notice water is standing on that foundation, you might want to consider resurfacing the foundation so water cannot accumulate there, because that will contribute to corrosion at the point where the steel and the concrete come together. Guy anchors are probably one of the most common causes of tower failures, and they can be really catastrophic. Many areas in the world have corrosive soil. The only suggestion I have is if you think you're in an environment like that, you really need to take some extra steps. Placing steel in direct contact with corrosive soils is probably not going to last for 10 or 20 years. And there are all kinds of horror stories about people who've put guy anchor rods in direct contact with corrosive soil and found out 10 years later that there's really not much of an anchor left. So if you have corrosive soil, you might want to think about using a concrete guy anchor and then only having the steel in contact with the concrete and not with the ground. A common error is for hams who are less experienced with towers to kind of go to the local hardware store that sells items to homeowners and buy guying material and guying hardware from that homeowner store. Well, that's a really bad idea. I've never seen heavy-duty hardware forged hardware for sale in these homeowner type stores. You really want to buy all of your guying hardware from a company that sells towers, and they will have the right stuff, and there's plenty of those companies around the world, and that's where you want to buy this hardware. If you really can't find anything like that, then an industrial supplier that supplies to the shipping industry or to crane companies will have the right hardware also. But you're better off to buy it from a tower distributor. Use the tower manufacturer's design for the guy anchors. If you do have corrosive soils, engage a professional to design that guy anchor if you can. If that's not practical, be sure that there's no steel and concrete in contact with that soil. And you always hear from hams that want to put up elevated guy anchors. It's a very common thing that you might want to do to keep lawn equipment and people away from the guy anchors. But if you want to do that, it really should be, that design for an elevated guy anchor should be done by a professional. Just going to the local hardware store, buying some pieces of pipe, putting it in the ground with a little bit of concrete is likely to lead to a tower failure. So this is one of the few areas in this presentation where contacting a professional to design those elevated guy anchors could save you a lot of trouble. And in terms of maintenance, this is another area to look at every 3 years. If you have steel in contact with the earth, as you might with a galvanized steel guy anchor, just take a shovel and dig down 6 inches on one side of the anchor and make sure there's no unexpected corrosion there. If there is any, time to start thinking about replacing that anchor. And look for missing hardware or loose hardware, corroded hardware. I usually keep a pretty good track of this, but I was replacing some old guy wires just 2 weeks ago, and I was shocked to find that one of the bolts on one of my turnbuckles was nearly completely loose, and that could have led to a disastrous failure, and I had missed that. That particular anchor was in a place that was a little hard to get to, and I don't think I had actually checked that particular bolt in quite some years. It's probably been loose for a long time, and that could have been disastrous, but thankfully we caught it, and hopefully that's the only one. So I'll just focus on the importance of anchor rod corrosion. So it's useful every 3 years or so just to get out the shovel and just take a look at that anchor and make sure it's okay. I think I went one too far here. Guy wires. Don't use that homeowner grade guy wire material or galvanized wire clips. Get it from a hardware company. Use the manufacturer's recommended guy wire size. This is an area where you don't want to use guy wire that's smaller. If it says use 1/4 inch EHS, use that, not 3/16. And also don't use heavier wire either, because you have to tension it heavier and you reduce the capacity of the tower. So use the recommended guy wire size. It's recommended that you tension the guy wires at about 10% of the breaking strength of the guy wire. Precision isn't important here, but about 10%. If it's about 7% or less, the guy wire will be noticeably loose. And when you get a heavy wind, the tower is going to have excessive movement as it tightens that guy wire. And similarly, if the guys are too heavy, it reduces the capacity of the tower and also risks guy wire vibration. For those of you who use fiberglass rod for guy wires, that's what I use rather than Philly strand or steel. If you're in an area that's clear of obstructions, you might have a problem with vibration. And if you do notice vibration in your guy wires, it's important to do something about it, because that can damage your tower. You can buy from Preform, the same company that makes the Preform guy wire attachment hardware, you can also buy vibration dampeners. So if you notice vibration on your guy wires, you really need to do something about it, because it can lead to catastrophic failure. In terms of maintenance, this is one area, because there are so many attachments, that it's a good idea with guy wires to inspect them 3 months after the tower installation is complete. And then once every 3 years is okay. And also, if you ever have a very serious storm, either very heavy ice accumulation or very intense wind, it's a good idea to check your guy wires after that too. Once every 3 years, you should check the guy wire tension. Once you get used to what a guy wire looks like when it's under the proper tension, usually you can just grab it with your hand and give it a good tug, and you can tell when it's approximately correct. If the guy wire moves a lot, it's too loose, and if it barely moves at all, it's probably too tight. Guy wires can get damaged by rubbing or chafing on other objects, especially other antennas or other guy wires, so be sure that there isn't any rubbing or chafing. I'm in the midst right now of replacing all of my guy wires. They're 25 years old, and corrosion has gotten to be a problem. So if your guy wires are getting to be 25 years old, if you start to see rust on them, it's a good idea to start replacing them. And I already mentioned the loose bolt that I found on my guy wires a little earlier. Another very important consideration is the point where the guy attaches to the tower. If you're using a guy tower, you should be using the tower manufacturer's design. And none of them recommend running the guy wire around a tower leg. They all have attachment hardware, and that's what you should be using. Should be using professional hardware, as I mentioned earlier. Turnbuckles should have safety wires around them to make sure they don't unwind. Many of you have probably not heard of this term, articulated guy wire connections. What this means is, and in the wind, the guy wires are going to move, and they should be free to move. And the hardware you use for attaching the guys to the tower should allow free movement of the guy in any direction, about 10 degrees. So if you're using shackles and that kind of hardware, you'll get this kind of free movement. If you don't have this free 10-degree movement, it's really not a properly done installation, and could damage the guy wires over time. And I actually did have a failure of this kind years ago, where I attached a guy wire directly to an anchor without any intermediate hardware, and the rubbing over years of the guy wire on the anchor ultimately caused the guy wire to fail. And I did not notice this until the guy wire was actually broken. So you really shouldn't be attaching guy wires directly to anchors. They should be attached through some intermediate steel hardware. So I'll just close this one out by saying do what the manufacturer recommends. And in terms of the guy attachment, in your once every 3-year inspection as you climb the tower, take a look, especially at the point where the guy's attached to the tower, and make sure all is well. At the guy attachment on the ground, make sure that those safety wires are still there and there are no missing pieces of hardware. You don't see any evidence of chafing or rubbing. When you climb the tower, or someone does that for you, carefully check for any damaged structural components on the tower, especially near the guy attachments where the forces are the greatest, and look for any broken welds. And if you find any degraded hardware, it's a good time to replace it. Well, if you're in an area with lightning, and most areas in the world are subject to lightning, part of the design of the tower should be the grounding system. And the kind of the minimum lightning protection system would be one ground rod adjacent to each tower leg. And normally those ground rods are separated from the tower foundation about 8 to 10 feet and separated from each other about 20 feet. Today, tower manufacturers recommend, believe it or not, using galvanized ground rods rather than copper. And the galvanized ground rods are readily available from electrical suppliers in the United States. If you can get a 10-foot length, that's the preferred length, although 8 feet is more common. And the tower manufacturers no longer recommend using copper wire to attach the rods to the tower. They recommend using tinned solid wire. And the reason for this change is to eliminate galvanic action. Copper grounding hardware and galvanized steel towers can lead to a corrosive environment, so the manufacturers no longer recommend using copper rods and copper wire. They're recommending use galvanized rods and tinned ground wire. In terms of attaching the ground rods to the tower, it's best to bury that wire between the ground rods and the tower base just to protect them. CAD weld is the preferred method, but there's other pretty good hardware out there sold by tower companies to attach wires to rods in the, and as long as you're buying that kind of hardware from tower distributors, you'll probably be okay. But CAD weld is the way to go. Never, never, never use braided wire outdoors. I've seen lots of hams that have used braided wire, and it degrades pretty quickly outdoors. It shouldn't be used. It's just an inappropriate place for it. In terms of maintenance, check your lightning protection system once every 3 years, mostly in missing hardware or any damage that might have occurred from lawn equipment or something of that kind. And if you find a problem, repair it. Antenna rotators. This is a troublesome area for a lot of hams. And this has become particularly a problem for hams that have installed these fairly popular monster Yagis. These are very large antennas, and most hams are unfamiliar with the kind of wind loads that these very large antennas with 60-foot elements will put on a rotator. And many of the hams that have put up monster antennas in the air have wound up ultimately going to prop pitch rotators. The normal ham rotators will not keep it up in the air in anything more than a fairly strong breeze. But even for antennas smaller than that, very seriously consider the capacity of the rotator for the antenna, particularly if you're in a high wind area or subject to ice loads. Use the manufacturer's recommended control wire, especially if the wire is longer than 100 or 150 feet. You might want to consider beefing up the control cable. Most of the rotator manufacturers have recommendations in this regard. The hardware you use for attaching the rotator to the mast and to the tower itself should be galvanized steel or stainless. And if you're using stainless hardware on the antenna or the antenna rotator, be sure to use anti-galling compound. Otherwise, you're likely to be surprised with nuts that literally get welded to the stainless steel bolts, and you won't be able to get them off again without breaking them. So when you're building that new system, pay careful attention to that rotator and don't undersize it, or it could make for a system that doesn't last for 5 or 10 years, but that maybe in a year or two will require major maintenance. The antenna rotator is another one of these areas where you should inspect it 3 months after you install it to make sure nothing is slipping or no hardware is loose, and then every 3 years after that should be okay. You might take a look at your antennas in the wind and make sure there isn't any unusual mechanical movement. And then when you do that 3-year inspection, look for corroded hardware or hardware that's become loose. So antennas and masts. Be sure to, when you're thinking about the kind of antenna you're going to install, that you give due attention to the wind and ice conditions in your area. If you live in a normal suburban area at relatively low altitudes and not on a ridge, then the normal ham antennas designed for moderate loads will probably be fine. But if you're building the antenna system of your dreams up on a very high exposed hill or mountain, there's a pretty good chance you might need to purchase custom-built antennas or to build your own, or to purchase some of the heavier-duty ham antennas that are out there rather than the less expensive ones. I've already mentioned galvanized and stainless steel hardware. That's very important in antennas. Hardware will not last very long exposed to the weather like hardware will be exposed at the top of a tower. I always put vibration dampening in all of the elements of my antennas, and just rope loosely run through the middle of the elements does a pretty good job of vibration dampening. I've never had an element break from vibration in all the years that my antennas have been up. And another fellow was helping me build one of my antennas a year ago and noticed me putting this vibration dampening rope in the elements and said, "Gee, I didn't think anybody did that anymore." Well, some of us do. And he commented, "Gee, I thought that's kind of an old way of doing things." Well, aeolian vibration has not gone away. It's still a problem, and if your elements vibrate in the wind, they will ultimately fail. And vibration dampening helps to get that kind of long life out of those antenna elements. Transmission lines. Probably the most likely place for those to fail is right at the point where they attach to the antenna. And it's important to pay careful attention to how the transmission lines are mechanically attached to the antenna itself and electrically attached. You don't want to have copper in contact with aluminum, for example. Usually stainless is a good buffer between copper and aluminum. If you do place copper and aluminum directly in contact with each other, the corrosion will damage that joint in a relatively small number of months if you get any rain. And if the antenna is of any size at all and uses a boom truss to strengthen that boom, this is another case where you want to use good, high-quality professional hardware and not consumer-grade wire or hardware. It won't last, and then the whole antenna system could fail because a few dollars was saved on the boom truss. So think about your local wind and ice conditions and pay careful attention to some of these checklist items if you're in anything other than a kind of a benign area.
Frank, before you start your next slide, we do have a question from Paul, and this may have been answered already, but he wanted to know what you use for vibration dampening, and I think that maybe it had to do with ropes and the elements of your antennas, and you had mentioned earlier also about dampeners for the guy lines. I don't know if there's anything else you want to add to that.
Yeah, Paul, I think I answered your question. I'll just reiterate it again since obviously you're interested. I run a 5/16 diameter rope through the middle of my antenna elements from end to end, and then let it rest, not under tension, but just rest loosely in the element, and then seal both ends of the element so the rope doesn't fall out. The idea is that the rope can move freely inside the element, so as the element moves, the movement of the rope will tend to damp out that antenna element movement, and especially the kind of vibration. It's not just the normal movement in the wind, but actual vibration. And if you've ever seen an antenna element vibrate, it tends to happen on the calmest days rather than on windy days. And if that vibration is present, sometimes those elements will only last a matter of a month or two before they actually fail. And if you look at an element that has failed in that way, it kind of looks like a very fine saw has been used to cut very cleanly right through it. So this is important.
And we do have one other question in that regard too, and asking rope through each element. And I think basically the answer is yes.
Yep, through each element. Yep. Every single element in my antenna system has a rope running through it.
I'll just second real quick what you're saying, Frank, because we had an issue at NR4Ms with the OWA 20-meter antennas we put up. Steve has got he always has a constant breeze through there, and you can just, if you're near the tower, you can just kind of hear the vibration. And a year or two after we put up the antennas, elements started breaking off. And so what we've rebuilt them now. We've gone to a bigger schedule on the elements, but we've also put rope in there as well. And you know, so far so good.
Yeah, well, good. I haven't had any of my elements break after 25 years, but I started this practice at my other location before that, when I did have some of them break, and some of the old-timers knew exactly what to do, and they were right.
Okay, I've got another question here. They're just starting to come in, Frank. This one is from K4XZ. When I obtained the building permit for my tower, I was required to use a single-point ground system per NEC Chapter 8. Is that your preferred way of installing a ground system?
Of course, I think your single-point ground refers to the point of entry into your home. And this presentation doesn't really deal with those issues. Single-point ground should never really refer to the base of the tower or anything actually having to do with the tower itself. Rather, the point where all of your coaxial cables, control cables, and any other electrical service coming into your ham shack all come together and are and you place the protection on that panel. And that's really not the topic of this presentation today. But single point ground is something you can learn about on the tower torque reflector, or you could probably use Google to find out more detail about the design of a single point ground at the point of entry into your home or your ham shack.
Okay, another one just came in. What is the best way to seal element ends?
Well, there's a variety of ways to do it. Some of the tower manufacturers provide a kind of a plastic boot that goes over the end. You can go to some of the hardware suppliers. One of the ones I like is McMaster Car, and they have a website. I think it's mcmastercar.com. I'm not sure, but if you go to Google and just type in MCMASTER, they have an online website, and one of the things they sell is attachments that go on the bottom of chair legs, metal chair legs. And they sell them in all kinds of sizes in 1/8 inch increments, and they're very heavy duty since they can go on the bottom of a chair, and you can just slip those onto the end of an element. The other thing you can use, and I've done this frequently and it works fine, if you use a high-quality electrical tape, such as Scotch 88, you can use that electrical tape to seal the ends of the elements, and it will last forever. And it's undoubtedly the least expensive way to do it, and it'll work just fine.
Okay, a couple more here. All of a sudden they're starting to pour in, Frank. And Cullen asks, how would you put ropes in a stepper? Well, I think the answer to that is you obviously wouldn't. And you know, I'm not sure if those elements would need any sort of dampening or not.
I don't think they would need dampening, because I think that tape, the copper tape that runs through the element, would probably serve that purpose.
Okay.
But no, you definitely cannot put ropes in those elements.
Yep. Bill Perkins, what type of tool procedure can you recommend for tensioning Kevlar guys? I guess that would refer to the Philly strand.
Yeah. Well, the bottom of your guys should transition to steel. All of the tower manufacturers will recommend that you transition to steel for the bottom 10 feet at least of the guy wire. And then you can use any of the normal tensioning tools to do that. I don't remember the name of that particular tool. Someone might recall, but K7LXC sells those tools. The The one I use and a lot of other hams use is sold in sailboat stores. They're tools that are used to tension the stays on masts on sailboats, and those tools cost about $50, and the calibration is fine for guy wires. Be sure you get one that's a suitable size for your guy wires, though.
Okay, John has a follow-up question on the ropes here, and he says, okay, not a solid rope, but through each element, right, with a question mark. So yes, I think the answer is you want an element, rope in each element, and I think you had mentioned before or had some suggestions on the type of rope.
Yeah, the size is not particularly important, and you know you can use a very inexpensive rope here, because the rope will not be exposed to weather. It'll be inside the element with both ends sealed. So you could use old, used rope, or you can use inexpensive rope. There's no reason to use anything that costs very much money for this purpose.
Okay, let me just see. Okay, boy, we're getting a bunch of questions in here. John also asks, is this on a Tenadyne? And I think that's log periodic. I think maybe one distinction, Frank, is I don't know. Well, some of the commercial antennas that maybe provide rope if they feel it's necessary. Some don't. But all of your antennas are home brewed, so maybe on some of the commercial antennas this isn't a necessity, or.
It's hard for me to imagine that it wouldn't be. One way that some manufacturers get around this problem is with fairly severe tapering, so that you don't get mechanical resonances.
Right.
But I'll tell you that I would put a piece of rope in there. It's so inexpensive, and if you do get into a situation just like Ken described, if you hear vibration coming from your antenna, boy, watch out. You could find some of those elements laying on the ground in a year or two.
Yeah, if nothing else, the stack that Steve had still worked, albeit probably not as good as with all the elements, but it sure looked ugly. Jack has a question about putting expandable foam in the ends of elements prior to putting the end caps on, and I'll just say, at least at NR4Ms, what we did is we put a little bit of sealant in there to kind of secure that end of the rope. Not that that's real important, but we did that, and then slipped the end cap on, and I suppose some of that sealant was on the element tip as well, and probably helped to secure that cap.
Yeah, you know, I'm not sure that I like the idea of putting expandable foam in the end. One of the things you're going to discover from the wind-driven rain is that no matter what you do, some water is going to get in that element. And I think it'll also get in just from condensation. So you do want a way for water to be able to get back out of that element.
Okay, and a couple people are mentioning that the tensioning tool is a loose tensioning tool. And,
LOOS.
Yeah. And Mike W3MC, he's probably got a professional version of the tensionometer. Yep. Or dynamometer.
Mike has worked on these towers, and Mike also did a lot of the repairs here after a microburst damaged many of the antennas.
Okay, hang on.
And Mike, you'll be happy to know that all the work you did 15 years ago is still holding up just fine. Thank you.
Okay, looks like one other thing, and then maybe we'll get back to your slides here, Frank. Any special recommendations as far as telescoping or crank-up towers, maybe some of the stuff you've covered so far?
I think my most honest answer I can give you, Ken, is that I have absolutely no experience with crank-up towers, so I don't think I would trust any advice that I would give.
Okay, very good. Then why don't you go ahead and continue on with the slides, and if you have some more questions, send them in, and we'll get back to them here in a minute.
Okay, well, I think we'll go on to the next slide. Oops, I've gotten into this frozen situation. Now I know how to correct it. Okay. Let's see. Transmission lines and other cables. If you're going to have a tower up in the air for a long period of time, ultraviolet is a factor. And I installed my antenna system 25 years ago, and a lot of my control cables are type UF electrical cable. Well, believe it or not, the UV, after about 15 years, started degrading that stuff pretty badly. So I've had to replace quite a bit of it. So I think this is a case where selecting the right cable and then doing inspections. But type UF cable is no guarantee that UV is not going to get to it. Most of those cables, the jackets, are completely vanished after 15 to 20 years. So the cables that are hanging from your tower are going to get subject to a tremendous amount of ice load if you're in an area that's subject to ice. Certainly a lot of wind also. They should be well attached to the tower as the cables drop down the tower. A very simple material to use for that is that's commonly used by professionals is number 12 solid insulated copper wire. You can form that into a nice attachment onto the tower, and it's inexpensive, and you can just do it by hand. Don't need any special tools. For those that prefer to use tape, a good high-quality tape such as Scotch 88 is also a good choice. Transmission lines should be electrically fastened to the tower also, at the top of the tower and the bottom of the tower. This is a very excellent practice for lightning protection. You don't see it very often done in ham installations, but it is the practice that really should be followed. Let's see. I guess we've gotten to the end. No, sorry. I managed to get one ahead of myself here. And in terms of transmission lines maintenance, every 3 years you should check for loose, missing, or UV damaged cables and cable attachments. Those cable attachments are important, particularly if you get heavy ice or wind. Transmission lines are very, very easily damaged by water entry. And paying attention to waterproofing all of the cables and connectors at the top of the tower and elsewhere on the tower is real important. And there are two materials that most professionals use for doing this. Good quality electrical tape such as Scotch 88 that's applied directly to the cable, and then that layer, actually 2 layers of Scotch 88 to tape once from the bottom to the top and then back down to the bottom again, and then cover that with a self-vulcanizing tape. Many of us use Scotch 130C, 130C. Follow the manufacturer's directions, which means that the sticky side of that tape faces out, and put 2 layers of that tape on and then cover it with Scotch 88 again. It's relatively inexpensive to protect connectors and cables with this 3-layer approach, but it's pretty much foolproof. And every joint that I've ever taken apart that I've protected in that way looks like the day it was installed. Another very good investment for checking the quality of transmission lines is time domain reflectometer. They're available on eBay, used for a very modest price, and anyone who has a sophisticated antenna system should think about trying to acquire a TDR. It will literally allow you, from the comfort of your shack, to check every foot of your transmission line from the shack all the way up to the point where it connects to your antenna. A good quality VSWR meter or watt meter, such as a Bird watt meter, is a good investment. But these things should be used in conjunction with good records. So when you check the performance of your antennas using a TDR or a VSWR meter, record the readings at various frequencies across the useful range of each antenna. And when you go back and do those measurements again in 3 years, in my case, since we use my station competitively, every October I go through every single antenna in the station and compare the measurements I've made against the records, and any change is not good. Whether if the VSWR appears to have gotten better, it usually means water has gotten into something. So keeping good records is very, very helpful. And kind of the takeaway at the bottom here is degraded transmission lines seriously affect station performance, and usually this happens gradually. And the performance of your station erodes so slowly that you might not even notice that you've lost a lot of the investment you've made. So let me just wrap up the whole presentation here. This whole presentation really was a set of checklists. I'm sure this presentation will be available online, or you can find just the slides on w3lr.com under the 2006 Dayton Antenna Forum, where this presentation was originally given. The checklist will help you avoid common design and construction errors. Very, very few hams have an organized inspection program. You should think about doing that every 3 years or after any major storm. It's a very important factor in long-term tower and antenna reliability. And Ken, that's the end of my prepared remarks. I'll be happy to answer any other questions.
Excellent, Frank. Okay, yeah, we have a couple more questions here. The first one from Mark is on vertical runs of coax on the tower. Do you have to worry about the dielectric migrating downward over time?
Hello, Mark. Normally that's not the case, although I can tell you that when I first built my antenna system 25 years ago, I used RG17 on my vertical runs, and it did migrate. And in fact, what migrated actually was the dielectric inside the braid of the cable. So I stopped using RG17 after a few years after that. But I've never had RG213 or Heliax cable migrate, and that's mostly now on my towers I use Heliax cable, and that's not a problem. But with RG17 it was a serious problem.
Okay, another one from Wayne. You had your tower painted a few years ago. How is it holding up, and what type of paint did you use?
Well, W2GD did that work. Yeah, John did that work, I guess 3 years ago. It's holding up very well. My towers are actually quite old. I installed them 25 years ago, but they were military surplus and probably had been in use at least 25 years before I had acquired them. But the paint is doing quite well. Like any paint, I would expect after 5 or 6 or 7 years it'll probably need redoing, but at the moment it's doing fine.